Hi, I am Dr. Eli Kolberg from Unlimited Robotics, and in this video I will talk about electric current. Free electrons move randomly from one atom to another. It is not noticeable outside of the material. If there will be a way to force free electrons flow in a directed and organized way along a conducting wire, an electric current that flows through the wire will be created. Organized movement of electric charges creates electric current. Definition of current. Electric current is a directed and organized movement of free electrons along a conductor. In order to create directed and organized movement of free electrons, there is a need for creating a difference between the free electrons concentration and the atoms with less electrons, meaning positive charge. This potential difference between the negative and positive sides will cause electrons flow towards the positive charge. This is called potential difference or electric voltage. Potential difference can be achieved by a voltage source like a battery. Next figure presents electrons movement that create electric current under voltage in a conductor. The negative electrode of a battery is called anode and has a concentration of free electrons. The anode is marked with a minus sign. The positive electrode of a battery is called cathode and has a lack of free electrons. The cathode is marked with a plus sign. Conclusion. In a closed circuit, the electrons flow from the negative terminal or anode to the positive terminal or cathode. Historically, the marking was arbitrarily determined such that the electric current flows from the positive terminal to the negative terminal in a closed circuit. It is not correct, but it does not affect the calculations and the phenomena related to electric voltage. We should just bear in mind that the mark of the direction of the current flow is opposite to the electron flow direction. We would like to know the amount of current that flows in a circuit in order to decide if the circuit is functioning properly as defined. It is also desired to be able to calculate proper operation of a circuit. The amount of current in the circuit is related to other factors as voltage and resistance that we will learn in future lectures. The current unit is called ampere and is marked with the letter A. For example, a current of 2 amperes will be written as 2A. 1 ampere is equivalent to a charge of 1 coulomb per second that flows through an electric circuit. It can be written as I is equal to Q divided by T, where I is the current value with units of ampere, A, Q is the charge value with units of coulomb, C, and T is the time in units of seconds, S. The formal definition of ampere is the constant current that flows in two parallel conductors with infinity length or negligible cross-section placed in a distance of 1 meter between each other in a vacuum and produce a power between these two conductors with a magnitude of 2 times 10 to the power of minus 7 Newton for 1 meter length. You can see the demo of current definition as we defined in the previous slide. 1 ampere is equivalent to approximately quantity of 6.24 times 10 to the power of 18 electrons that flows through a point during a period of 1 second. An electric current is basically electrons flow through a conductor. Normally, it is not possible to see electrons without using a microscope. An analogy of water stream might help better understanding electrical circuits. The mechanical water system presented in the next figure contains a pump that enables raising the pressure and pushing the water through a closed pipe. You can see at the top a mechanical system with pump that push water in a pipe and has some resistance that we see the gravel that is used as a resistance. At the bottom we see an electrical circuit the battery pushes a current through a metal wire, and we see a resistor that resists the current flow. In the mechanical system, P equals F over A. We can multiply the numerator and denominator, the numerator by D, distance. F times D equal to E, and A times D equal to V, where P is pressure, F is force, A is area, D is the length unit, E energy, and V volume. In the electrical system, V equals E over Q, where V is voltage, E is energy, and Q is charge. In the two systems, the motive force, pressure or voltage, equals the energy divided by the amount of flow, water volume, or amount of charge. The definition of current is also similar in both cases. In the mechanical system, the volume flow is defined as N equals V over S, where N is the volume flow, V is volume, and S is time in seconds. In the electrical system, the current flow is defined as I equals Q over S, where I is electric current, Q is electric charge, and S is time in seconds. Thank you very much for having with me in this video. Hope to see you in the next one. Bye bye.